All right, hey guys, this video is going to go over some special type of equations. So we've been solving equations. Today we're going to get to some different looking equations and we are going to see if we can solve them. So please follow along on your note sheet. You can have your calculator out as well. If you are at home, you can just take notes right in your notebook. All right, so I have this first problem. Let's go ahead and read through it. It says, in a pig race, your pig gets a head start of 3 feet, and he is running 2 feet every second. So he's going at a pretty good pace. Your friend also has a pig who is in the race, and this pig is also running 2 feet per second, but that pig doesn't get a head start. I want to know, when will these pigs be at the exact same spot in the race? All right, I'm going to pause and I want you to think about, when will they be at the same spot in the race if they're running? All right, so hopefully you kind of thought to yourself, well, if one pig gets a head start, so if I got this one pig, he starts 2 feet ahead of the other pig and they're running at the same pace, they should never kind of catch up to each other. So sometimes you can have a problem where there is no answer. This equation actually has no solution. If I was going to write an equation, I'll just kind of show you. If I had pig A and pig B, okay, pig A gets a head start of 3 feet, so he's already 3 feet in, and he's running 2 feet every second. So I'm going to write 2 feet per second. Pig B does not get a head start, and he's running 2 feet every second. This is what my equation would kind of look like. Now, I want you to pause the video, and I want you to just try to solve this. All right, now you may have gotten some kind of weird solution to this equation, and that's what we are going to learn about today. So I want you to take a look. Last year when we were first learning how to solve equations, we used algebra tiles, and they kind of looked like this. All right, so I've got a balance here. Right now I'm going to tell you, I want to know, when could I get these two scales to weigh the exact same amount? Will this scale ever be balanced? Okay, well, let's kind of think about it. On this side, I have 2 x's. This side, I also have 2 x's. Okay, so those are the exact same amount. So if I just had this and this, it would weigh the same. But this side has 2 extra 1's. Okay, so if I kind of wrote an equation, this side has 2 x's. This side has 2 x's plus 2. Will these ever be equal? Well, if this is the same amount on both sides, it would be equal if it looked like that, but this side always has 2 extra. So there is actually no solution to this problem. No matter what number I would put in for x. Let's say I said, hey, what if x was 5? Well, if all of these x's were 5, this side would weigh 10. This side would weigh 10 plus this 2, which is 12. So that wouldn't be equal. Okay, if I picked another number for x. Maybe I said, okay, what if x was 4? Okay, and I put 4's here. Well, this side would now weigh 8. This side would weigh 8, 9, 10. They're never going to be equal because this side has those 2 extra 1's. So there is no solution. So take a look at what this equation looks like. It says 2x equals 2x plus 2. It kind of has the same thing on both sides, and then this has an extra thing. If you have an equation that looks like that, the answer is no solution. All right, so let's actually try to solve an equation, and then we'll see kind of what we notice. So if I gave you an equation like this first one, 5x plus 9 equals 5x plus 7. Okay, right away you might notice, like, hey, they both have 5 x's on each side. And then one has a 9 on the side, one has a 7 on the side. So if you thought of it like a scale, you might think like, hey, if the 5 x's were on both sides, they'd be balanced. But then this one has 9, this one has 7. It probably won't be balanced, but let's just see what happens if I solve it. So usually I tell you to start with the x's. So if I took away the 5 x's from both sides, okay, let's see what happens. On the first side, I end up with 9. On the second side, I end up with 7. If you had a scale like that and you had 9 and 7, would they ever weigh the same? They would not. That is not true. So you kind of end up with a not true statement. If you end up with something like that, it means the answer is no solution. There's nothing that you could put in here for x that would ever make the scale balanced or would ever make that equation true. Okay, the reason for that is because you have the 5 x's on both sides, and then the 9 and the 7, those are never going to balance out because they're 2 different amounts. And that number there, the 9 and the 7, those are called the constants. If I don't think I mentioned that. So the constants are different, so they are never going to be the same. Okay, let's look at the second equation. Again, you can do this one with me. So the first thing I would always probably do is I would distribute. I'd say, okay, 2 times x is 2x. 2 times 4 is 8. Okay, so on that side, I get 2x plus 8. On the second side, I need to combine like terms. So if I have x plus x, that's the same as 2x. All right, so now right away, you might kind of notice like, oh, hey, look at this. They both have 2x's on that side. Okay, so that part would be balanced, but then this other side has an extra 8. That side's always going to weigh a little bit more since this part's the same, but this has an extra 8. Right away, I maybe notice, hey, there's no solution. Those sides will never be balanced. Now, if you don't notice that, you can say, okay, I'm going to take away 2 x's from both sides. Let's see what happens. I end up with 8 equals, on this side, I have 0. Now, again, if this was a scale, you'd have 8 on one side, 0 on the other side. That would not weigh the same. So this is a not true statement. I end up with 8 does not equal 0. That's what that little symbol means, does not equal 0. So the answer is no solution. There's no answer to that. All right, let's try another one. Okay, so I have this big, long problem. I can't just tell anything by looking at it. I have to do a little bit of work first. So I'm going to do 8 times 4, which is 32. And then I'm going to do 8 times negative 2x. Remember, this is a negative 2x, which is negative 16x. Okay, on the other side, I'm going to do 4 times 3, which is 12. And 4 times negative 5x is negative 20x. And then back here, I still have plus 4x. All right, now I am going to combine some like terms. So we always need to combine anything that's alike. So on this side, I see a negative 20x and a positive 4x. Okay, if I combine those, that would be negative 16x. Okay, and then I still have that plus 12. On the other side, I've got 32 minus 16x. All right, again, right away, you might notice something. It's okay if you don't notice it, but do you notice how they both have negative 16x? So I've got my variable, and they both have the same coefficient. That's called a coefficient, that negative 16. So those two parts are equal. If I had a scale, and those two things are on there, they weigh the same. Okay, so this and that are equal. So they're balanced if I just had those two. But this side has 32, this has positive 12. That's never going to be equal. Now, if you kept solving it, I would say, all right, let's get rid of the negative 16x. I could add 16x to both sides. Okay, those both cancel, they're gone. I'm left with 32 equals 12. Well, 32 does not equal 12. So if you end up with a not true statement, there is no solution. All right, so all of these equations that we just solved had no solution. Those are all special equations. And again, what you may have noticed is you might have something like this. You have your variable, and it has a coefficient of 4, and you have your variable over here and a coefficient of 4. They have the same coefficients. Okay, so that part's the same. But then the other part, the constant, just like the normal numbers, those are different. Then that would probably mean that there's no solution. And we'll take some notes on that towards the end of the video. All right, so we are going to take a look at another type of special equation. So I want you to take a look at this equation that we have here. And I want to know, is there something that you could put in for x that would make these two equations weigh exactly the same, or would make the scale be balanced? So I want you to think about this for a minute or two. I want you to pause the video, and I want you to try to answer these questions over on the side. What do you think the answer to this equation is? All right, so let's start thinking about this. If I was like, hey, if I was going to solve this, I could maybe say, hey, let's take this away from both sides and this away from both sides. That's gone. Let's take this away, that's gone. I'm left with nothing on the scale. Okay, you might have also noticed something different when you were looking at this. I'm guessing some of you noticed that, hey, it looks like the exact same thing is on both sides. They both have an x on the side, and they both have a 1. If that's the exact same thing, what could I put in for x that would make it true? Well, what if I put in a 5? What if I said, oh, x is 5? Well, let's see what this first side weighs. It'd be 5 and 1, which is 6. 5 and 1, which is 6. Hey, 5 is a solution. So is my answer x equals 5? Well, what if I put in a 2? Let's see if that would work. Okay, if I plug in a 2 here, if x was 2. Okay, well, I've got 2 plus this 1 here, so this side would weigh 3. And 2 plus this 1 here, this side would also weigh 3. Hey, so x equals 2. That's an answer. Man, I got 2 different answers so far. What if I pick a negative number? Let's say I said, what if the x was negative 5? Okay, well, I've got negative 5 plus 1 here, which is negative 4. Negative 5 plus 1 is negative 4. Hey, x equals negative 5. That's a solution. There are a lot of solutions. This is actually a special equation where any number that you would pick would work. Okay, and the reason for that is these are the exact same thing on both sides. They both have an x, so no matter what x is, that part's the same, and then they both have that plus 1. So the equations are the exact same on both sides. If you end up with something like that, that means there are an infinite number of solutions. Basically, that's telling you that every single number you could ever choose for x works. This is just the way that you write it. So there are an infinite number of solutions. So let's take a look and see what equations like that look like. Okay, so I have this equation. Let's try to solve it. All right, so obviously we got to do a little bit of work first. So I'm going to do 6 times x. I get 6x. 6 times negative 3, which is negative 18, and then it says plus 10. All right, right away I like to kind of combine my like terms. So I see a negative 18 and a positive 10. If I put those together, I end up with 6x minus 8. Okay, let's go to the other side. Okay, the other side, I'm going to do 2 times 3x, which is 6x, and 2 times negative 4, which is negative 8. Now, both sides look good. Now, right away, if you ever notice this, you don't really have to go too much further, but I'll still show you. Do you notice how both sides are the exact same? They have the same variables. They have x, they have the same coefficients, they both have 6, and they have the same constants. So they have the same everything. If you ever end up like that, you know whatever you put in for x, it's going to be equal. So you know that the answer is x equals an infinite number of solutions. Basically, every single number you could choose for x works. Now, if you didn't notice that, which is okay, you could keep solving it. Let's just see what happens. So let's say I take 6x away from both sides. Okay, that's gone. I end up with negative 8 equals negative 8. Does negative 8 equal negative 8? Yeah, that's true. If you ever end up with a true statement like that, when you're solving it, that tells you there's an infinite number of solutions. Now, if you kept going, if you're like, oh, you still didn't notice it, which is okay, I would say, oh, let's add 8 to both sides. Okay, that cancels. I'm left with 0 equals 0. Well, that's also a true statement. Okay, that's true. That's going to tell you that your answer is infinite number of solutions. I'm hoping that you notice it, though, way back here when you have the exact same thing on both sides. If you notice it there, you can kind of stop and just be like, hey, it's the same thing. Whatever I put in for x, it's going to work and give me an infinite number of solutions. Okay, let's look at a couple just to see what we notice. So if I take a look at this first one, okay, I've got 4x plus 7 equals 7 plus 4x. Now, right away, I'm hoping that you notice, like, hey, it's got the same variable and the same coefficient, 4x and 4x, they're both positive. And then it's also got my same constant, plus 7 plus 7. It's the exact same equation. So if you notice that, right away, you can say, hey, answer is infinite number of solutions. Anything works for x. Any number I choose would make that true. If you didn't notice it, you would say, oh, let's subtract 4x from both sides. Okay, that's gone. I end up with 7 equals 7. Well, that's true. That tells you there's an infinite number of solutions. All right, let's check out the other one. Okay, so sometimes you have to do a little bit of work first. So let's distribute. So 2 times x is 2x. 2 times 3 is plus 6. Okay, so I end up with 2x plus 6 equals 2x plus 6. Now, it looks like the exact same thing on both sides. So if you ever get something like that, you know the answer is there is an infinite number of solutions. Anything, again, that you would put in for x would work. If I put a 1 in here, the sides would stay balanced. If I put a 2 right there, it would work. If I put a 3, both sides would still be equal. So all of these equations have an infinite number of solutions.